What's up guys, Mr. Tutor here, and today we're going to be talking about gravitational fields. I have two problems for you guys, but it's going to be one problem for each video, and this is part 1, so we're going to begin with this problem, and in part 2 we will be working on an even more difficult problem. It should be fun guys. Let's start with part 1. So Jupiter, the largest planet in the solar system, has a mass of 1.901 times 10 to the 27th kilograms. The Earth has a mass of 5.979 times 10 to the 24th kilograms. If the distance between the two planets is 6.2853 times 10 to the 8th kilometers, what is the force of attraction between the two planets? Now don't get scared guys. I know these are big numbers right here, but this is why Mr. Teen Tutor is here. This is why you're watching this video. Mr. Teen Tutor is here to help you get rid of all of your fears and troubles. In order to solve this problem, we're going to use this equation. This is known as Newton's universal law of gravitation. This is the gravitational force between any two objects. So here's a quick photo representation. Here's object A and here's object B. It's not a great picture, but the force that actually represents the distance between the two. Well, you know what? Actually, I'll leave that. So this is the distance between the two objects, and the force between the two is known as Fg. And we're trying to solve for the force of the gravitational force between Earth and Jupiter. Now, you may be wondering in the first place, how is that even possible? The Sun is the only one that is pulling on all these planets. But the truth is, guys, the planets are pulling on each other as well. There you go. That must be mind-blowing for you guys. There's something new. Planets pull on each other, and the Sun pulls on all the planets. That's right, guys. That's how it works. So we need to find this. So it's equal to G, which is a constant, and that's equal to 6.67 times 10 to the negative 11th. That's a constant, and that will always be the case. So it's that times the mass of object 1 times the mass of object 2 over the radius squared. The radius meaning the distance between the two objects. So it's an inverse square relationship. So we're going to work with this equation in order to solve this problem. Now before we plug in numbers, we need to understand the units. The force is obviously measured in newtons. The mass is measured in kilograms. However, the radius or distance between the two objects is measured in meters. That's right, meters. In the problem, it said kilometers, which means that we're going to have to do some converting here to get to the proper units. Like I said earlier, don't be scared. I'm going to make this much easier for you guys. Now that you know what the units are, let's plug some numbers in. So we have G, and in your calculator you can say G is 6.67 times 10 to the negative 11th. You can program that into your calculator. So you have G times, and it doesn't matter if I list Jupiter's mass first or Earth's, because as you know, multiplication is commutative, so it doesn't matter. So we'll start with Jupiter's. So 1.901 times 10 to the 27th kilograms. You don't have to include units, but if you want to, that's fine. Just make sure that in your answer you don't forget units. Those are some silly points you don't want to lose. And then we have that's the distance between the two objects. We have to find Earth's mass, which is, there we go, right there, 5.979 times 10 to the 24th. And this is all over 6.2853 times 10 to the 8th. However, like I said, we need to get into meters. So there's a side note. 1,000 meters equals 1 kilometer. So if this is in kilometers and we want to get into meters, we multiply this value by 1,000. And then we square this whole quantity. Now you're probably looking at this and now, yes, it is getting pretty freaky and looks really complex. But you have a calculator. Teachers won't expect you to do this by hand. If a teacher expects that from you, then they're nuts. But you can use your calculator now, plug in all this, and you'll find the force. Make sure you don't make any silly errors. So I'm going to plug this into my calculator right now, and you can too. And I know the number's not going to be nice, but nevertheless, it's going to be the answer to this problem. And don't forget the times 1,000, guys. If you forget that, you're going to get the problem wrong. Or you may get partial credit on a test or quiz, but Mr. Teen Tutor's goal here for you guys is to get full credit on these kinds of problems. Alright, so I got 1.92 times 10 to the 18 newtons. Like I said, include the units. You don't want a line going through 18. You want to make sure it's as clear as possible. There you go, guys. That is the answer to this problem. That is the gravitational force between Jupiter and Earth. Now in part 2 of this video, we're going to work on a different problem where we don't need this answer. We need to know this equation right here to work problem number 2, which is going to be difficult, but like I said in the beginning of the video, should be fun. So, hope you guys watch part 2.